Good morning student, hope you are doing well. I am Faiyaz and you are watching Faiyaz classes. We are studying R.D. Sharma, page 22.03, section 22.3, angle between two lines. Okay. In this section we will study angle between two lines. Let's start. Suppose this is a Cartesian axis, okay, and there is two lines passing through two lines. This is first line, okay, and this is a second line, okay, and these two lines making an angle theta, okay. These two lines have angle theta between them, okay, and suppose this is line 1 and this is line 2, okay. Line 1 is making an angle theta 1 with the positive direction of x-axis, and this line 2 making an angle theta 2 with the positive direction of y-axis, okay. We know that slope of the line 1, if it has angle theta 1 is, so slope of the line 1, slope of line L1 is equals to tan theta 1, okay, and this slope is m1. We can say that slope of the line 1 is m1 is equals to tan theta 1. Similarly, m2, that is slope of the line 2, slope of the line L2 is equals to tan theta 2, okay. We know that we have to find the angle theta, okay, angle between two lines, okay. How can we find this angle? We know that in a triangle, suppose this is a triangle and the this point is A and this point is B and this point is C, okay. So in triangle A B C, okay, we can also name this point as D, okay. So in triangle ABC, we know that in any triangle, external angle of the triangle is equals to sum of the internal angle, sum of the opposite internal angle, okay. So in triangle ABC, we can say that theta 2 is equals to what? Theta 1 plus theta, okay. Theta 2 is equals to theta 1 plus theta, because why? Sum of interior opposite angle is equals to exterior angle, okay. So this angle theta 2 is equal to theta 1 plus theta. From here we can find theta is equals to theta 2 minus theta 1, okay. Now if we want to find tan theta, so how can we write it? Tan theta as tan theta 2 minus theta 1. We know the formula of tan A minus B. What is this? Tan A minus tan B divided by 1 plus tan A into tan B, okay. Now tan theta is equals to tan theta 2. We know that tan theta 2 is equals to m2 and tan theta 1 is equals to m1. So we can write tan theta 2 as m2 minus m1 divided by 1 plus m1 into, okay. Now angle theta is equals to tan inverse m2 minus m1 divided by 1 plus m2 into m1. Okay, so we get this formula for the angle between two lines. Okay, now angle between two lines can also be this angle is also the angle between two lines, and this angle is equals to pi minus theta. Okay, so angle between two lines is equals to theta and also pi minus theta. So if theta is equals to this, then what is the value pi minus theta? So we can write tan pi minus theta is equals to minus tan theta, and that is equals to minus m2 minus m1 divided by 1 plus m1 into m2. Okay, so this is also the angle between the line, that is pi minus theta, but in these two angles, one angle is acute angle and one angle is obtuse angle. Okay, so if we want to find the acute angle between the two lines, this is the second angle of the between the two lines. Okay, this can also be the angle. We can write it as pi minus theta is equals to tan inverse minus m2 minus m1 by 1 plus m1 into m2. So this is the second angle between the two lines. Okay, but in these two angles, this is first angle between the two lines and this is second angle between the two lines, and in these two angles, which angle is acute angle? So if we want to find only acute angle between the two lines, we can write theta as the acute angle. Suppose theta is the acute angle, so we can write this formula as tan inverse mod m2 minus m1 1 plus m1 into. Okay, this is the required formula for the acute angle between the two lines. This is the required formula for the acute angle between the two lines. Acute angle. Okay, why we use mod here? Because we want only positive values of these. Okay, suppose m1 is less than m2, slope of line 1 is greater than line 2, then this value is negative. So we use mod because we want to only find only acute angle, therefore we use here mod. Next is condition for parallelism of line. If two lines are parallel to each other, suppose this and this are two lines, and if these lines are parallel to each other, that means the angle between the two lines is theta, that is 0 degree. Okay, if two lines are parallel to each other, then theta is equals to 0. Theta is equals to 0. Okay, we can write that tan 0 degree, that is m2 minus m1 by 1 plus m1 m2. We know tan 0 degree is equals to 0, then by solving this we get m1 is equals to m2. This relation shows that if two lines are parallel to each other, that means that the slope of the two lines are equal to each other. Okay. Next topic is condition for perpendicularity of two lines. Suppose the two lines are perpendicular to each other. This is first line and this second line, and suppose these two lines are perpendicular to each other, then theta between these two lines is equals to 90 degree. Okay, so we can write here that theta is equals to 90 degree. Okay, now tan 90 degree is equals to m2 minus m1 by 1 plus m1 m2. By solving this, okay, tan 90 here, if we put the value of tan 90, it is infinity. Okay, so we cannot solve with this, so we just find the reciprocal of tan 90. Then the reciprocal of tan 90 is equals to cot 90, and here also reciprocal is 1 plus m1 m2 divided by m2 minus m1, and now cot 90 is equals to 0, and by solving this we get 1 plus m1 m2 is equals to 0, and from here we get m1 is equals to minus 1 by m2. Okay, so this is the relation between the slope of the two lines if they are perpendicular to each other. This relation shows that if two lines are perpendicular to each other, then their slope is negative reciprocal of each other. Okay, their slope is negative reciprocal of each other. Thank you. Okay, thank you.